why do you look so down?
I want to prepare for the NMMS, but I have no idea where to start.
Oh,
Don't worry, I'm here to help. Gory Smart Channel has everything you need for NMMS prep. Just check it out. Subscribe, like, and share.
Really? That's awesome. I'll subscribe to Gowrie Smart Channel right away. Thank you so much.
Today we will discuss about the heat lesson. Heat. What is meant by heat? Heat is a form of energy which transfers takes place from hotter body to colder body. Heat means it is a form of energy. Heat transfer takes place from hotter body to colder body. Hotter body to colder body. Heat always transfers from hotter body to colder body. Let us take an example of teacup. And here ice cream. Then what we will say? When they both are in thermal contact, means touch each other. Suppose I bring this ice cream near here and they both are in thermal contact, touch each other. What happens? Ice cream gains temperature from teacup and teacup loses its temperature. How much heat energy it loses, that much heat energy it gains. When they both are attained at the same temperature, then heat transfer stops. That state is called thermal equilibrium. What is meant by thermal equilibrium? When two bodies are in thermal contact, hot body loses heat energy and cold body gains energy till they both attain the same temperature. When they both attain the same temperature, then we can say that the two bodies are in thermal equilibrium. Let us take an example. A, B, C are three bodies. A at 45 degrees centigrade, B 45 degrees centigrade, C also 45 degrees centigrade. Then how heat transfer takes place? Here no heat transfer takes place. Why? Because they three are at the same temperature. That means these three are in thermal equilibrium. Then these three are in thermal equilibrium. In thermal equilibrium state, no heat transfer takes place. In thermal equilibrium state, no heat transfer takes place. Okay. Now, what is the relation between the kinetic energy of molecules and heat? Let us take an example. Take a Bunsen burner or stove, keep a vessel in this, heat up to some extent. Take another bowl of water with room temperature. Take two bowls, one is at room temperature and another one is heated up to some extent. Take food color, same amount of food color insert in these two bowls. What happens you will observe. At room temperature water, the molecules of food color moves slowly. The molecules of food color move slowly. But in hot water, they move rapidly, means very fastly. Based on this, what you can conclude that when temperature increases, kinetic energy of the molecules also increases. Therefore, how can we define the relation between the kinetic energy and heat? Means the average kinetic energy of the gas molecules is directly proportional to the absolute temperature. That you should keep in your mind, absolute temperature, not direct temperature. Absolute temperature means the temperature which is measured in Kelvin scale is called absolute temperature. The temperature which is measured in Kelvin scale is called absolute temperature. How we can convert temperature from centigrade to Kelvin scale? Temperature in Kelvin is equal to, you can get C plus 273 Kelvin scale. That is the relation. If you want temperature in Kelvin scale, you have to add 273 to the centigrade value. Then you can get absolute temperature value. The average kinetic energy of the gas molecules. Energy of molecules. The average, otherwise the average kinetic energy directly proportional to the heat, absolute temperature. The average kinetic energy directly proportional to the absolute temperature. Absolute temperature means the temperature which is observed in Kelvin scale. The temperature which is measured in Kelvin scale is called absolute temperature. To get absolute temperature, we will have to add 273 to the centigrade scale. Okay, why we have to add 273? Any other number we can add, but why we have to add 273? Here at minus 273 degrees centigrade, the kinetic energy of the gas molecules become 0. So that take it as standard value. Why? Because when you are decreasing the heat energy from the gas molecules, why you are taking gas molecules? Those are very wider comparatively to the either solids or liquids. Solids, the molecules are strongly bonded to each other, so we cannot separate that one. But in fluids, fluids means which flows are called fluids? Either liquids or gases are called fluids. In that fluids, liquids molecules are somewhat distance between comparatively to the solids, so it flows. Comparatively to the liquids, gas molecules are very deeper, distance maintains distance, so it can spread anywhere. So the average, they are moves, randomly moves and collides each other, they creates kinetic energy and heat also, due to friction heat also generates. When you are decreasing the temperature, the velocity of the gas molecules becomes decreases. At a particular temperature minus 273 degrees centigrade, the kinetic energy of the gas molecules becomes 0, means gas molecules are in stable condition, will come into stable conditions. That's why we take it as standard value. Minus 273 degrees centigrade is equal to 0 Kelvin. We take it as 0 Kelvin. This calibrate each degree, 1 degree, 1 degree, 1 degree up to go on. That's why we can call it as positive scale of temperature. Why? Because its value starts from 0. If you have negative value, both positive and negative value, you can say that. But the starting value in kinetic scale is, Kelvin scale is 0 Kelvin. So this is called positive scale. In the following, which is the positive scale? Reaumur scale, centigrade scale, Fahrenheit, Kelvin, they will give options. You have to write Kelvin scale. Remaining all have negative values also. Only positive values have to the Kelvin scale. To measure the temperature, we will use different types of scales. Here somewhat we are using heat, somewhat we are using temperature. What is the difference between the heat and temperature? Heat is a form of energy which flows from hotter body to colder body. But the temperature is the degree of hotness or coldness is called temperature. Suppose by touching a coffee cup, we can say that it is hot. How much hot it was, we asking. The intensity of the heat you cannot say. By using a device you can measure that. Which device we will use to measure the temperature of a substance? Thermometer. For substance it is laboratory thermometer, for human body it is a clinical thermometer. Okay, thermometer is a device to measure the temperature of a substance. Okay, what it will say is, it will says the degree of hotness or coldness. The degree of hotness or coldness is called temperature. Temperature measured in different scales, one is centigrade, Fahrenheit, Kelvin and Reamer scale. These all are the scales to measure the temperature. What is the relation between all these? We have a relation between these two. C by 100 is equal to F minus 32 by 180, that is equal to K by 273, that is equal, sorry, K by 100 is equal to R by 80. What is this values? You already learned in the 7th class how to prepare a thermometer. The melting point of ice taken as lower limit and boiling point of water is taken as upper limit. That 0 to 100. 0 degrees is the melting point of ice. 100 degrees centigrade is the boiling point of water. That divided into 100 equal parts and each denoted as 1 degree. So 0 to 100 degree we can measure. So that is the number of divisions in that scale. The downward value shows that the number of divisions in scale. Okay, in centigrade scale we are having 100 divisions. In Fahrenheit scale you have 180 divisions. Why take it as minus 32 and 180? Observe, minus 32 to 212. That is the range. This is minus 32 Fahrenheit degrees centigrade. Minus 32 degrees Fahrenheit, that is the melting point of ice. 212 degrees Fahrenheit is the boiling point of water. Understand? That how many divisions are there in between these C? 180 divisions. That's why F minus 32 by 180. In the same way Kelvin scale, it starts with 0 and 100. That means what? 0 degree centigrade is equal to 273 Kelvin. See, 0 degree centigrade is equal to 0 plus 273. So 273 Kelvin. 273 Kelvin is the melting point of ice and 373 Kelvin is the boiling point of water. In the same way, Reamer scale also 0 to 80. Number of divisions 80. We can calculate by using this formula. We can convert from one scale to another scale by using this formula. This is very important. This formula we should always keep in your mind. C by 100 is equal to F minus 32 by 180, Kelvin by 100, that is equal to R by 180. Generally we did not discuss about this Reamer scale. These three are very important. Next, let us see about the units. What is the unit of heat? What is the unit of heat? Heat is denoted by Q. To find out the unit, first we have to find out the formula for heat. How we can calculate the amount of heat used to heat a substance, isn't it? To raise the temperature of a substance, we need heat. Without giving heat, there is no increase in its temperature. Okay. So, what is heat? What are the parameters affects the heat? Let us see. For suppose, let us take an example of 250 milliliters water in one bowl, 750 milliliters water in one bowl, and give same amount of heat to two boils at same time, either 2 minutes or 3 minutes or 5 minutes, whatever it may be. Understand? Time is constant and the given heat is constant. Which will have more temperature? 250 milliliters. Which have small amount, it gains more heat. Which has more amount, it will gain less heat. The giving heat is also equal. So, the given heat is depend upon the mass of the substance. Here the 250 milliliters, 750 milliliters means it is the mass, quantity of substance, that is depend upon the quantity of substance. So, Q is proportional to M, isn't it? Next. Take equal amount of substance in two bowls, either water or any substance you can take. Equal amount of substance. Okay, suppose take in one bowl, heat it for 5 minutes. What happens? Its temperature nearly 30 degrees centigrade. For 10 minutes, 40. For 15 minutes, 50. What's happening? When we are increasing the time, what happens? The temperature also increases gradually. Temperature also increases gradually. Understand? So what will becomes the difference? What gives the difference? Time difference gives the unit time. Time difference gives you the unit time. In that unit time, what is the temperature difference? T2 minus T1. Understand? For first minute, it is 30 degrees centigrade. For the next minute, it is 40 degrees centigrade. The difference in time is 1 second only, that is 1 unit. For unit of time, what is the difference between the temperature? That is called delta T. Q is proportional to delta T, change in temperature also. When the time increases, the temperature also increases. Understand? So, Q is proportional to delta T. Q is proportional to M. Q is proportional to delta T. So, Q is proportional to M delta T and Q is equal to MS delta T. This is the formula to measure the heat quantity. Understand? Q is proportional to MS delta T. M is the mass of the substance and delta T be the temperature difference in temperature. That means final temperature minus initial temperature. Otherwise, temperature of hotter body minus temperature of colder body. Why? Because always heat transfer takes place from hotter body to colder body only. Heat transfer takes place from hotter body to cold body only. That's why the temperature difference means temperature of hotter body minus colder body. Q means given heat. Then here what is S? That is called specific heat. That is called specific heat. Then what are the units of heat and specific heat? Both. Specific heat I will tell later. Next let us see about the Q. Q means heat. What are the CGS unit and SI unit? What is the CGS unit of heat? Calorie. What is the SI unit of heat? Joule. Heat is nothing but energy. For energy we are having units joules. Okay. Joule means we will denote with capital J. What is the relation between these two? 1 calorie is equal to how many joules? 1 calorie is equal to 4.186 joules. While doing calculations, we can use 4.2 joules. For simplification, we simplify that one. Okay? 1 calorie is equal to 4.186 joules. That nearly equal to 4.2 joules. That is the relation between the units of CGS system and SI system. Next, let us do one experiment to know about the specific heat. To take a bowl, you take a bowl, okay, take water in this. The temperature of water is 60 degrees centigrade. Consider at 60 degrees centigrade, take water. Next, slowly at the edges of that bowl, you pour coconut oil. It forms a layer from the water surface. So, down it is water. In upper layer it is coconut oil. 2 thermometers insert in both. See, one thermometer kept in water, another thermometer kept in oil. Observe the calibrations in the thermometer, reading in the thermometer. If you observe carefully, the temperature of the water slowly decreases and the temperature of oil is slowly increases. By this experiment, what you can conclude? Temperature always takes place, heat transfer takes place from hotter body to colder body. Okay. From this experiment, we can conclude that the heat transfer takes place from hotter body to colder body. In the same manner, we can do another experiment. See, take a white bowl, and take water at nearly either 60 or 80 degrees centigrade. Take 2 test tubes. In one test tube oil and another test tube water. Take one test tube in oil and another test tube water. Insert in this. Equal amount. You have to take equal amount of oil and equal amount of water in 2 identical test tubes. Okay. Fit with stands and observe. Keep thermometer in both test tubes and observe the reading in temperature. What happens? The temperature in oil rapidly increases, but the temperature in water slowly increases. We are giving equal amount of heat to the both test tubes. In one test tube we take water, in another test tube we take oil. Understand? Oil gradually, rapidly increases the temperature, but in water it will take more time to attain the same temperature. Understand? Means what happens? It slowly getting heat. It immediately gaining heat from the source. Understand? Why? We are giving same amount of heat, the quantity of the substance is also same, the vessels means the test tubes are identical test tubes. Why there is a difference in temperature? That is called specific heat, that is depend upon the nature of substance only. That is called specific heat, that is depend upon nature of substance. Oil rapidly increases its temperature. When you take out these both, oil gradually immediately decreases its temperature also. It will easily heats up and it easily lose the heat. Understand? Means cools. So which has specific heat more? Water has specific heat more. The substance which has more specific heat, it will get more time to get heat, as well as it will get more time to become cool. Understand? So specific heat is depend upon the nature of substance. Specific heat depend upon the nature of substance. See, from this formula you can get the formula for the specific heat. Q is equal to ms delta T. From this we want S. S is equal to what happens? Q by m delta T. Specific heat S is equal to Q by m delta T. Then what are the units of specific heat in CGS and SI units? What is the CGS unit? Q means heat, calorie, per, mass, gram. Temperature difference means temperature, degrees centigrade. Temperature units in CGS system is centigrade, in Kelvin system is, SI system is Kelvin. That you keep in your mind. So, calorie per gram degree centigrade is unit for specific heat in CGS system. In SI system, joule per kilogram Kelvin. Joule per kilogram Kelvin. Calorie per gram degree centigrade in CGS system and joule per kilogram Kelvin in SI system. This is about the specific heat. Okay. What is the specific heat of water? For water it is, specific heat of water is equal to 1 calorie per gram degree centigrade. Specific heat of water. For kerosene and ice, specific heat is 0.5 calories per gram degree centigrade. Why? Because it is important for solving the problems. They will always give heat from ice to water conversion, water to vapor conversion in problems. So we should know the value of specific heat of ice also. That is 0.5 calories per gram degree centigrade. When water cools and forms ice, the density becomes less. That's why ice cubes float on water. The density of ice is less than density of water. So ice cubes floats on water. Okay. This is about the specific heat. How can, suppose two substances are at different temperatures. When we mix both, what will become the final temperature of that mixture? In previous we already know that when two substances of different temperatures in thermal contact, heat transfer takes place from hotter body to colder body. When up to they both attain the same temperature, that state is called thermal equilibrium. Okay, when two substances are mixed, that is called mixture. What happens to the final temperature? That is called method of mixture. In the method of mixture, how we can calculate the temperature of a mixture? Let us see. In method, what is the formula for the method of mixture? Method of mixture means net heat loss is equal to net heat gain. Which body loses the temperature, the equal amount of temperature will be gained by the colder body. When there is no heat change from the surroundings, isn't it? Not only the two bodies, from surrounding atmosphere also gains some temperature. So, we consider that there is no temperature difference in the surroundings. There is no heat transfer or heat gaining from the surroundings. Then only we can apply this formula. Understand? That's why we will use calorimeter. Calorimeter is a device which do not allow the heat from outer side to the inside. At the same time, inside temperature will not go to the outside. To measure the temperature of a specific heat of a substance, we use calorimeter. That is the device. Okay. Now let us see method of mixture. What is the formula from the method of mixture is net heat lost is equal to net heat gain. Net heat lost is equal to net heat gain. Let us consider two substances of different masses. M1 is the mass of the first body, T1 is the temperature of the first body, and S1 be the specific heat, but we can take water. In both substances are water. Consider that both are water. The specific heat of water is 1. So, no need to write there. Okay, specific heat of water, the value is 1 calorie per gram degree centigrade. For water, specific heat is 1 calorie per gram degree centigrade. Suppose other than water if you take means you have to add specific heat also. Okay, M2 be the mass of the second substance and T2 be the temperature of the second substance. Consider that T1 is greater than T2. So, which is the hotter body? First body is the hotter body and the second body is the colder body. So, first body loses temperature and second body gains the temperature. So, the thermal equilibrium temperature, final temperature, when they both mix, the final temperature of the mixture is equal to T. Then according to method of mixtures, net heat lost is equal to net heat gain. Who loses the temperature? First body. So, Q1 is equal to Q2. Q1, first body heat is equal to second body. How much heat gained by the second body is Q2. Q means MS delta T. We already know that one. So, M means M1, mass of the first substance. Substance is water. So, specific heat S is equal to 1. No need to write. And the temperature difference T1 minus T2. Sorry, T1 minus T. Why? Because the final temperature becomes T. T1 loses its temperature up to T. T2 gains temperature up to T. So, T1 minus T, that is equal to M2 into T minus T2. T1 minus T, that is equal to M2 into T minus T2. If you simplify this one, M1 T1 minus M1 T is equal to M2 T minus M2 T2. Take this M2 T2 here and this M1 T2 to the that side. Then M1 T1 plus M2T2 is equal to M1T plus M2T. In this both common T, so M1 plus M2 into T. We need T. Therefore what happens? M1 T1 plus M2T2 by M1 plus M2. This is the formula to measure the final temperature of a mixture. This is the formula to measure the final temperature of a mixture. T is equal to M1 T1 plus M2 T2 by M1 plus M2. M1 be the mass of the substance, T1 be the initial temperature of the first body, and M2 be the mass of the second substance, T2 be the temperature of the second substance. To attain the final temperature T, the formula is M1 T1 plus M2 T2 by M1 plus M2. This is called method of mixtures. By using method of mixtures, we can find the final temperature, that means thermal equilibrium temperature of the system. Next, how to measure the specific heat of a solid? How to measure the specific heat of a solid? Let us take. Specific heat of a solid. By using method of mixtures formula, by using method of mixtures theory, we can find the specific heat of a solid. Here we are having, I already told that to measure the specific heat of a solid we use calorimeter. Okay, here calorimeter, we will take water in that calorimeter. They both are at the same temperature. Calorimeter and water both are at same temperature. In lead chamber, we are taking lead shots as a solid. We have to find out the specific heat of the lead shots. We can take the lead shots, keep in steam chamber. In steam chamber, the temperature is at 100 degrees centigrade or 100 degrees centigrade. When we can take that 100 degrees centigrade temperature, the lead shots, insert in this calorimeter water. What happens? The lead shots loses its temperature and calorimeter as well as water gains the temperature. Okay, the loss of heat by the lead shots equal to the gain of heat by the calorimeter and water. Then how we will get the specific heat of the lead shots? Let us see. Mass of calorimeter plus stirrer. By using stirrer, we can mixer method becomes mixer very fast. That's why is equal to M1. Next, mass of calorimeter plus water is equal to M2. Take water in that calorimeter and measure the weight of the calorimeter and water M2. But we want mass of water. How will you get mass of water? Substituting M2 minus M1, you can get mass of water. Mass of calorimeter plus water minus mass of calorimeter gives you the mass of water. Okay. Temperature of calorimeter and water is equal to T1, initial temperature. They both are at same temperature initially. Next, take lead shots. Next, mass of calorimeter plus water plus lead shots is equal to M3. When you add lead shots from steam chamber, you bring that lead shots, and when you add in water, calorimeter, water and lead shots are there in only. That time you weigh the weight of that calorimeter, you can get M3. But you want only mass of lead shots. Mass of lead shots. that is equal to M3 minus M2. Mass of calorimeter plus water, subtract from calorimeter plus water plus lead shots. Then you can get the only mass of the lead shot, that is M3 minus M2. The temperature of lead shot is equal to T2. Steam chamber it is at 100 degrees centigrade. Lead shots are at 100 degrees centigrade. So, lead shots are the hotter body and water and calorimeter are the colder bodies. The temperature of the lead shots is T2. Now, thermal equilibrium temperature. When you add lead shots at the steam chamber to the calorimeter, then what happens? Lead shots decreases, lead shot loses its heat and calorimeter water gains heat. So, therefore, the thermal equilibrium temperature, that means the temperature of mixture, that is equal to T3. What does it mean? From T2 temperature to T3 gradually decreases by the lead shots, and from T1 temperature to T3 temperature gradually increases by the water and calorimeter. Now, according to method of mixtures, let us take specific heat of calorimeter. Specific heat of calorimeter is equal to SC. Specific heat of water is equal to SW. Specific heat of lead shots is equal to SL. We have to calculate SL only. Specific heat of lead shots SL. Now, according to method of mixtures, net heat loss is equal to net heat gain. Which loses the heat? Lead shots. Therefore, heat loss by lead shots is equal to heat gain of calorimeter plus water. Heat gain of calorimeter plus heat gain of water. Now, heat loss by the lead shot, what happens? Heat means here Q is equal to MS delta T. Mass of the lead shot M2 minus M3. Specific heat of lead shots SL into temperature difference T2 minus T3. T2 is the temperature of the lead shots and T3 be the thermal equilibrium temperature. That is equal to heat gain of the calorimeter. Mass of the calorimeter is M1 and specific heat of calorimeter is SC and temperature difference is T3 minus T1. Why? Because T3 be the thermal equilibrium temperature and T1 be the initial temperature of the calorimeter plus heat gain by the water. Mass of the water M2 minus M1 into specific heat of water SW into temperature difference T3 minus T1. But we want here, if you observe carefully, T3 minus T1 is common in both. Take common that one, M1 SC plus M2 minus M1 into SW total into T3 minus T1. But we want specific heat of the solid here, lead. So, that is equal to SL is equal to, this is the formula to measure the specific heat of a solid, M1SC plus M2 minus M1 into SW whole into T3 minus T1 by M2 minus M3 into T2 minus T3. This is the formula to measure the specific heat of a solid. This formula is very important to do the problems. To solve the problems, it is very important. Formula you have to by heart. That should you keep in your mind. SL is equal to M1SC plus M2 minus M1 into SW whole into T3 minus T1 by M2 minus M3 into T2 minus T3. This is about the how to measure the specific heat of a solid. Next, we have specific heat is depend upon nature of substance. In our daily life, we have observed so many things in about the specific heat. Let us take an example of samosa. Let us take an example of samosa. You observe that outer part of the samosa is cool, but inside the curry is very hot because the ingredients to prepare curry has more specific heat than the outer layer of the samosa. That is one of the example in our daily life. In the same way, when you take watermelon from the fridge, it will take more time to become cool. Why? Because it has more amount of water. Nearly 90% of water it contains. Water has highest specific heat. So it will take more time to cool, becomes cool, as well as it will take more time to lose its temperature also. So from comparatively to the remaining fruits, watermelon attains more coolness from the atmosphere when you take from the fridge. That is also one of the example for the specific heat. As well as if you take a boiled egg, inside you all more heat than the outer part. Why? Because the specific heat inside is more than the outer part. This is also one of the example. Land bridges also, sea bridges also we can take. Daytime, land time becomes more heat immediately, and at evening, night time it cools rapidly. But in the daytime, the sea water to heat up more, it will take more time. At night time, it releases heat more. That's why we can call it as heat sources. Oceans are called heat sources due to the highest specific heat of water. This is also one of the reasons for the highest specific heat of water. We already know that water has a special nature. It attains in 3 states. The solid form of water is called ice, and the liquid is water, and vapor state is called, gaseous state is called water vapor. These all are reversible reactions. When you heat up ice, it becomes water. Again giving heater, water becomes water vapor. When water cools, water vapor cools, it becomes water. And when it again cools, we can get ice. So it has it changes its state. Okay. In that we are having some important things regarding this. Let us see. Evaporation, condensation, solidification, as well as melting and boiling. Including all these, again we have another one is dew and fog. We have to know all these things in this lesson. The first one is evaporation. What is meant by evaporation? At any temperature, escaping of water molecules from its surface is called evaporation. Here evaporation and boiling, in both cases we observe that water changes its state to vapor. In these 2 cases, evaporation means escaping of water molecules from the surface of the liquid at any temperature. At any temperature evaporation takes place. At a particular specific temperature boiling takes place. In these 2 also water changes its state to vapor. But at any temperature evaporation takes place. At a specific temperature means 100 degrees centigrade only. In boiling water changes its state. Next, what are the factors affecting the evaporation? Let us see. Factors affecting evaporation: large surface area, wind speed, temperature and humidity. These are the factors affecting the rate of evaporation. How it affects the rate of evaporation? What does that mean? Rate of evaporation means the time increases. The evaporation takes place either slowly or fastly. That is called rate of evaporation. For large surface area, take a two bowls. One is in a cap and another one is bowl. Take same amount of spirit in these both. Observe after some time. In the bowl, spirit which is in bowl evaporates more, and the bowl which is in cap, the spirit which is in cap will take more time to evaporate. We take same amount of spirit. But what is the difference? The bowls are different. One has wider surface and another one has less surface. So which has more surface area? Evaporation takes place more. That is called increases. Rate of evaporation increases with large surface area. Rate of evaporation increases with large surface area. Next, let us see wind speed. We all know that when our clothes becomes dry when there is a lot of wind is there. Wind blows more, the wet clothes becomes dry fast. So wind speed also increases the rate of evaporation. Rate of evaporation increases with wind speed. Temperature. Wet clothes becomes dry in a sunny day than a rainy day. In sunny day, wet clothes becomes dry because the temperature is more. So if the temperature is more, the rate of evaporation also increases. Next, humidity. What is meant by humidity? Humidity means the amount of water vapor present in the atmosphere is called humidity. When humidity is more, the atmosphere not ready to receive more amount of water vapor from the surroundings. So humidity decreases the rate of evaporation. See, if you observe when rain falling also we feel becomes sweat inside the room. Why? Because rainfall means it is actually cool atmosphere, but we feel sweat inside the room. Why? Because the water vapor does not exist in the atmosphere, because already it present more amount of humidity in the atmosphere, more amount of water vapor. According to with large small surface area, it has more water vapor, so it not ready to receive any water vapor from the surroundings. So humidity decreases the rate of evaporation. Rate of evaporation decreases due to humidity. So the evaporation, the factors affecting the rate of evaporation are large surface area, wind speed, temperature and humidity. In remaining all these three also, large surface area, wind speed, temperature increases the rate of evaporation, but humidity decreases the evaporation. When the atmosphere has less humidity, evaporation takes place more. When it has more humidity, evaporation takes place less. This is about the evaporation. Next, evaporation is called cooling process. Evaporation is called cooling process. Why? Because to become water becomes to vapor, it attains energy, heat energy from the surroundings. So it gains the energy, surroundings becomes cool. When evaporation takes place, the surroundings becomes cool. That's why evaporation is called cooling process. Next, condensation. Water vapor changes its state from vapor to liquid is called condensation. In the process of condensation, water vapor loses its energy. Then it condenses as water. What happens that energy? That energy enter into the atmosphere. So when a condensation takes place, the surrounding atmosphere becomes warm. That is called cooling. Condensation is a warming process. Condensation is a warming process. Why? Because heat energy loses. Here it is gaining energy. So the surrounding area becomes cool. But here it losing energy. In condensation, water vapor loses its energy and becomes water. That energy enter into the surrounding atmosphere. That's why the surrounding atmosphere becomes warm. That's why condensation is called warming process. Next, solidification. Solidification means liquid changes its state to solid. Here also it loses some energy. It loses some energy and becomes solid. Liquid changes to solid. Water loses its energy and becomes ice. Is called solidification. Next, melting. When the substance changes its state from solid to liquid is called melting. From solid to liquid is called melting. So, let us take an example of ice. When you are giving heat to the ice, it ready to becomes water. Till the total ice becomes water, there is no change in its temperature. Temperature remains constant till the total amount of ice becomes water. So, what happens to the giving energy, heat energy? What we are giving heat energy, what is happening? There is no temperature rise in the ice. What happens? The total energy completely used to change the state of the ice to water. So, that is called latent heat of fusion. Latent heat of fusion. What does it mean? The heat energy used to change its state only, not raising temperature. The latent heat of fusion for ice is 80 calories per gram. The latent heat of ice for ice is 80 calories per gram. What does it mean? To 1 gram of ice completely changes its state to water, the required heat energy is 80 calories per gram. If you are giving 80 calories to the substance of 1 gram of ice, it completely becomes water without raising its temperature. That is called latent heat of fusion. Next, boiling. Boiling means here also it is the change of state from liquid to gaseous state. Liquid to gaseous state, boiling here. What happens? When there is a change in its state, there is no rise in temperature. The given heat only used to change its state. For water it is 540 calories per gram. 540 calories per gram. What does it mean? 1 gram of water to become completely as vapor, the amount of heat required is 540 calories. 1 gram of water, completely it changes its state from liquid to gas. The required amount of heat is 540 calories. That is called latent heat of vaporization. This is called latent heat. Latent heat of vaporization. The value of latent heat of vaporization is 540 calories per gram. The latent heat of fusion is 80 calories per gram. How we can calculate? Here we are having a formula. Q is equal to ml. Here latent heat L is equal to Q by m. For vaporization or fusion, whatever it may be, the formula is latent heat is equal to Q by m. Q means the given heat energy and m means the mass of the substance. Q by m. So, what is the units of latent heat? Q means calories per gram or joule per kilogram. Calories per gram in CGS system, joule per kilogram in SI system. Next, dew. What is dew and what is fog? In winter season, we observe that in the outer atmosphere is cooler than the room temperature. Sometimes what happens, the amount of water vapor condenses and forms as water drops in the surfaces of the leaves, window glasses, etc. Those are called dew. The condensed water vapor in window glasses or grass or leaves of the plants are called dew. What is fog? Sometimes water vapor present in the atmosphere condenses on the dust particles in the atmosphere. We are having so many dust particles which floats on the surface of the earth. In that dust particles, the condensed water droplets are condenses water vapor. That seems like a fog, mist. The thick mist is called fog. It seems like a fog. That is called fog. Fog means the condensed water vapor on dust particles is called fog. Thank you.